multiple choice question on calculus of several variables. The first question is evaluate and a triple integration 1 to e 1 to e integration from 1 to e 1 divided by x y z dx dy dz, and options given are a is equal to 1, b is equal to e, c is equal to e square, and d is equal to e cube. So here now, since all the here the limit of integrations are constant of x, y, and z, so we can directly evaluate this integration, or you can take this integration as 1 by x 1 to e dx, 1 by e 1 by y dy, and 1 to e 1 by z dz. So we know that the integration of 1 by x is ln x into ln y into ln z, and all these limits are from 1 to e 1 to e and 1 to e. This is equal to, we know that ln e is 1 and ln 1 is 0. By using this, the value of this limit is 1 into 1 into 1 is equal to 1. So the answer is equal to here the option number 1 a, that is 1. Next example, evaluate an integration 1 to e 1 to e 1 divided by xy dx dy. Again, if you see, and options are given, a is equal to 0, b is equal to 1, c is equal to e square, and d is equal to e, and options are given again. This example is same as previous example. All the limit of x and y is are constant here, so we can write this is 1 to e 1 by x dx and 1 by e 1 by y dy by using Fubini's first theorem, and this is equal to again ln x from 1 to e into ln y from 1 to e. So this is equal to ln e is 1 and ln 1 is equal to 0. By using this, the value of this term is equal to 1. Value of this term is 1, so it is 1 into 1 is equal to 1. So again, option number B, the correct option is what? Option number B. Now next example, example number 3. If r is a square, if r is a square, 1 less than or equal to x less than or equal to 2, and 1 less than or equal to y less than or equal to 2, then double integration 1 upon xy dx dy is equal to what? And options are given. A is equal to log 2, a is equal to log 2, b is equal to log 4, c is equal to log 2 raised to 2, and 4 d is equal to what? 4. So here again, the given region, if you draw the region, you can see here 1 less than or equal to x less than or equal to 2. Suppose here 1 2 and here 1 and 2, then the region bounded by these lines are, this is the line. So the limit of x is 1 to 2 and limit of y is also 1 to 2. Both limits are constant. So again, this double integration 1 divided by xy dx dy over the region R is equal to 1 to 2 1 divided by xy dx dy. So it is equal to, since again limits are constant, so you can evaluate, you can apply Fubini's first theorem. You can evaluate integration x and y at time. So here is equal to, the integration of 1 by x is log x and integration of 1 by y is equal to log y, and again limit is from 1 to 2. So again we know that log 1 is 0, so this is log 2 minus log 1 into again log 2 minus log 1. This is equal to log 1 is 0, so this is log 2 into log 2, it is equal to log 2 brackets log 2 square. So the correct option is what? The correct option is C, option number C. Next, example number 4. Example number 4. If u is equal to x minus y and v is equal to twice x plus y, then the value of dA by uv divided by dA by xy is equal to what? And options are given. A is equal to 3, b is equal to minus 3, c is equal to 1 by 3, and d is equal to again minus 1 by 3. So here given u is equal to x minus y and v is equal to twice x plus y, and we want to determine dA by uv divided by dA by xy. It is equal to, this is nothing but the Jacobian of xy, so this is equal to dA by u divided by dA by x, dA by u divided by dA by y, dA by u, sorry, just 1 minute. DA by u divided by dA by x, and dA by v divided dA by u divided by dA by y, dA by y. This is what dA by v divided by dA by x and dA by v divided by dA by y. So it is equal to dA by u divided by dA by x is 1, and dA by u divided by dA by u divided by dA by y is minus 1. Then dA by v by dA by x is equal to 2, and dA by v by dA by y is equal to 1. This is a partial derivative. So if you simplify this, it is equal to 1 minus 2. So this is 1 plus 2 is equal to what? 3. So this is what dA by u v divided by dA by xy. It is dA by u by dA by x, dA by u by dA by y, dA by v by dA by x, dA by v by dA by y. So the correct option is what? 3. A, option number A, 3. Next example number 5. Example number 5. Which of the following statement is correct? We want to identify which of the following statement is correct. The option number 1, if limit xy tends to x0 y0 f of xy exist if and only if limit along every path exist and all are equal. This is the first option. The second is if two repeated limit exist. And equal, two repeated limit exist and equal, if two repeated limit exist, then simultaneous limit exist. Then simultaneous limit exist. Option number 3, if limit xy tends to x0, limit xy tends to x0 y0 f of xy exists then the function then the function so exists then the function f is continuous at x0 y0, continuous at x0 y0. And number 4, if two repeated limit exists, then function f is differentiable. If two repeated limit exist, then the function is f is differentiable. Function f is differentiable at x0 y0. So from this 4 statement we want to decide which one is the correct option. Now first, if we consider the second option, if two repeated limit exist, then simultaneous limit is also exist. This is a false statement, because if we consider f of xy is equal to xy divided by x square plus y square, for this example both the repeated limit exist, but still this simultaneous limit does not exist, because if we take the path along y coordinates, we get the different limit along the different path. So this statement is false. Now third statement, if limit f of xy exists, then the function f is continuous at x0 y0. Now again, this is not true. If the simultaneous limit exists, then the function is continuous at x0 y0. So we want the value at f of x, when we said it is a continuous, if limit xy tends to x0 y0 of f of xy is equal to, the limit at this point should be equal to f of x0 y0, then we can say that the function f is continuous. Again, if the two repeated limit exists, then function is differentiable at x0 y0. Again, this is not true, because it is a differentiable, then it is a continuous. If we take here f of xy is equal to xy divided by x square plus y square, here both the repeated limit exist, but this function is not differentiable because it is not its limits does not exist. So the correct option is what? If the limit xy tends to x0 y0, f of xy exists if and only if the limit along the every path exists and all limits are what? Equal. Along every path we get the same limit. Now the next example number 6, if f of x y equal to x square plus xyz plus z, then find the partial derivative f of x at 1 1 1 and the correct options are given 0 1 then 3 and d is equal to what? -1. So here we want to determine partial derivative of f at x. Now when we take a partial derivative with respect to x, means what? Our y is constant, so f of x is equal to twice x plus yz plus 0. The derivative of this term with respect to x is 0. Here derivative of x is 1 and here twice x. So f of x at 1 1 1 is equal to 2 into 1 plus 1 into 1. So this is what? 2 plus 1 equal to what? 3. So the correct option is what? 3. Now the next example number 7. The Jacobian of coordinate transformation. What is the Jacobian of x is equal to r cos theta and y is equal to r sin theta of transformation? That is, we transform here x and y to polar coordinate, and we want to determine what is the Jacobian of this transformation. That is, we want to determine Jacobian of r theta, that is, it is equal to dabba xy divided by dabba r theta. Okay, so we want to determine this, and the options are given is equal to a is equal to 1, b is equal to r, c is equal to r square, and d is equal to what? 0. So here the Jacobian of r theta is equal to dabba xy divided by dabba r theta, which is equal to determinant dabba x divided by dabba r, dabba x divided by dabba theta, dabba y divided by dabba r, and dabba y divided by dabba theta. So if you simplify this, it is equal to dabba x divided by, what is x here? X is equal to r cos theta and y is equal to r sin theta. So dabba x by dabba r is equal to cos theta, dabba x by dabba theta is equal to minus r sin theta, dabba y by dabba r is equal to sin theta, and dabba y by dabba theta is equal to r cos theta. So this is equal to r cos square theta plus r sin square theta is equal to r times cos square theta plus sin square theta, which is equal to 1. So the Jacobian is equal to what? R. Jacobian is equal to R. Next question, example number 8. Find the domain of the function f of xy equal to, find domain of the function f of xy is equal to log of under root of x square plus y square. Now again we know that the square root function is not defined for negative values, but since x square plus y square is always greater than or equal to 0 for every xy in r square, but again this log 0 is undefined. Log 0 is undefined, and this term x square plus y square is 0 only if x is equal to 0 and y equal to 0, and therefore if we remove the single point r square minus 0 0, then for every point this function is what defined, and therefore the domain of this function is r square minus 0 0. Number 9, if the simultaneous limit exists and has the same value along any different path, then if the simultaneous limit exists, the question is if simultaneous limit exists and has same value along any different path, and has same value along any different path, if the simultaneous limit exists and has the same value along any different path, then first limit xy tends to ab f of xy is exist, then number 2, limit xy tends to ab f of xy may or may not exist, then C, limit xy tends to ab f of xy does not exist, limit xy tends to ab f of xy does not exist, and number 4, can't say. Now here if the simultaneous limit exists but the point is not given, okay, and has same value any different path, but what point here, the point ab is not given, or the x0 y0 is not given, so the correct option is what? We can't say anything about when limit xy tends to ab may or may not exist, or we cannot say anything, so the correct option is what? 4. Then next number question number 10, the set of points xyz in a space where a function of three independence variable, function of three independence variables has a constant value f of x y z equal to c, then it is called number 1, option number A, level curve of f, number B, level surface of f, number C, codomain of f, and number D, domain of f. So the correct option is what? It is called the level curve of f.